Hello everyone. So today in this runtime generated world system, we are going to implement integrate procedural foliage system that we already have in Unreal, these foliage types, and integrate multiple foliage types into our foliage generation system. So here you can see there are two types of foliages, and one is growing mostly on the highland, and this other type is growing mostly closer to the water. So if I select the BP word, here you can see the foliage types that I have given as the input. So earlier we were using these common parameters that supported only one foliage type, but now we have an array, and this is actually this foliage type asset that we can already create within Unreal. So here we can assign a mesh and define height range, slope range, Z offset. There are many options that are already here, so I'm going to integrate that into the world generation system that we have been working on. So by using this system, now you are not limited to only one foliage type. You can have many foliage types as you want. So yeah, let's see how to do this today. And before we get started, I'd like to remind you that you can download the project files of this project and all other projects that I have done in my channel. To the date, there are over 1700 videos. For each video, you can download the project file once you become a member in the Patreon page. So that would help me to keep doing what I'm doing here. So feel free to check it out. And back to the tutorial. Right, so in the current system, there is only one foliage type that I have added. So what I want to do is having multiple foliage types, and also there should be some rules regarding at what elevations, so what angles these different types of foliages that can grow. So for that, so at the moment, these are the parameters that I have regarding foliage. This is only one parameter, like this is designed to have only one foliage type. So that's why we have mean altitude, growth property, so these things. But this system is not extendable. So what I want to do is to allow adding multiple types of foliages. Here in the engine, we already have this static mesh foliage, and let me name it FL5. So if I open this, here we already have this placement. This is min height, max height. No, this is min Z offset, max Z offset, and ground angle, height. So all those things are already here and more. So I want to integrate this type, this foliage types, into this current system, so that instead of one, we can have many foliage types. Okay, so I defined the one for pine. So let me just set the values here. Here we have this cluster size and this offset variation we used, but I don't think we have something similar here. But I remember if I enable procedural foliage, we can get some additional options. Right, let's try that. Okay, maybe we have to reopen it. Yeah, here we have clustering. So this part, so this is number of steps, initial seed density, average spread distance. These things are similar to these cluster size, instance of set, things like that we define. So the cluster size is 10. Average spread distance, that means this instance of set, it's 100, sorry, 1000, and this is 200. And I haven't really implemented the other anything similar to these other parameters, so let's look into them later. Now let's see how to integrate these foliage types into the existing system. So I think ideally we can have foliage types should be in the type of foliage instanced static mesh component. Foliage instanced static mesh component. Okay, and it has to be a array and public. Now here foliage types, I can add this. Oh wait, I can't add this. Static mesh foliage. What's wrong? The type is foliage type. Oh, maybe this one. Yeah, now I can add it. Okay, so let me here in the begin play. Now for each foliage type we need to add instanced static mesh component. This is the one that I had already added. But that way is not going to work, because we can have any number of foliage types, and for each foliage type we need to have instanced static mesh component. Therefore, let's say, let me add a function, initialize foliage types. Okay, now we need some space. We don't need these two. Let me delete them. And here in the begin play, initialize foliage types. Then here for each, let's add foliage. No, wait, what's the function? Static mesh component. Add instanced static mesh component. Okay, now I'll promote this to a variable, a local variable, fl type, no, ism comp, right, and then we can set mesh. Oh, we can't set mesh. We can get, but we can't set. Here we can select. Oh, we can. I just had to type set static mesh. Okay, and from this, get mesh and set it. Alright, what else we need to set? We need to set this call distance and collision preset, I guess. So set call distance get call. Oh, we can't access it. Oh, was there a different name? No, it is there. Under instance settings, we do have call distance. So maybe that data is not exposed to blueprint level. That's fine. I'll just not set it. Later on, if we have to, we will go into C++ and do these things, but for now let's just stick with blueprints. So the main thing is setting the mesh. Also I'll set collision. No, that's not necessary for now. So yeah, after we add these instanced static meshes, we need to access this. So for that we need to store references. Maybe let's create another array. Let me promote the store variable and not a local, global variable. I'll name it foliage components, and I'll turn this into an array. Okay, now get add this reference. Okay, now where we use this? Oh, in a lot of places, unfortunately. This is gonna take some work. So this is, let's first look into add-in part. Now here, after this line trace, now since we are going to have multiple foliage types, we need to determine which foliage type that we are going to spawn here. So this check and this height check, I think that is something that should be happening in that part. So let's collapse that part to a function, but before that let me do another break and give this location separately so that it wouldn't make any unnecessary inputs and outputs. Okay, collapse to function, get relevant foliage type. Right, let's go inside. Now here, so I don't think this check is necessary because we are going to, this check would work because what we are checking is if we are hitting on any other foliage types, any other foliage instances. So maybe we should check if it is terrain for now. Later on, let's define a surface type based method function, but for now let's just make it only spawn on terrain. So terrain mesh is the head component. If that is true, we can spawn foliage there. Okay, Oh, one more issue. So maybe instead of using this to get relevant foliage types, let's rename this. Add relevant foliage instances. Okay, and let's break it from here. Now this will break our system that we have implemented to replace instances when they are in a distance style. So we will restore it later on. For now, let's work on this. So here, let me remove that. For each foliage type, we need to cycle through all the foliage types. So get foliage types for each. Here, get height. So this will give us min height and max height. This is in world space. Now from the location, we can break and check the Z component. If this is less than, oh no, I think there is a in range. Yeah, this in range option. So if this is true, that means we can add, no, not yet, this foliage height check passes. So hold on. So this part is actually the cluster, and within the cluster this part is happening. So okay, this function should actually be here. In fact, we should replace this. Find references, add foliage instances. Should be here. So instead of this one, add relevant foliage instances. Okay, now instead of it, we will only get a location. So location vector. Right, now here, let me get rid of this location and along with this whole set. So here we can use the location. Now then, let's replicate this part. So we don't have here. Let me copy this. Okay, now we don't have a growth probability percentage, something similar to that here. Actually we do, maybe something like this initial seed density or something can be used, but as I understand this, in this blueprint level we can't access it. So we will rely on this common value for all foliage types for now. and cluster size also the same. Now after the hit, if we do get a hit, let's see if break this, if this hit component is equal to the terrain. So for now what we are thinking of is only on the terrain mesh we are going to place foliage. And also again, if we want, we can do this height check, but for now I think I'll allow it, because if the main point is within the range, that should be enough for now. Now here let me promote this to a local variable. I'll call it active foliage index type index. And then here I get this foliage components, and from this component I'll get a reference using this 𝐂𝐻 for active foliage type index, and then add instance. Now as for the location, split this, we can get the location, and to this location, if we want, we can add this element. Let me run this to another local variable, active foliage type. In fact, I think we should do this setting after this branch check, because before that we don't really need to use them. Right, get active foliage type, offset, so here we got a min and a max, so we can define a random plotting range min max, and that's the location. As for the scale, curve, okay, we have a curve. Well, I don't want to use that for now. What do we do here? Right, oh, we have this procedural scale. Maybe that is something we can use. Oh, unfortunately that is also not accessible, so let's use this thing that we already have for now. For the scale. Okay, so later on we will properly integrate fully with C++ for the things that we can't access in blueprint level, or we will have to create additional variables, maybe create a subclass from this type and make things blueprint accessible or something. Let's think about that later. Is that all? Oh, something is missing here. Location, yeah. Okay, shall we test? Right, So it is working with the new foliage type integration. So we just have to, this height range, we need to save it. So at the moment here we have min height, we only have a min height which is 300. So here, where is it? 300. I'll make it 300 to 500 to 1000, just to see if it is working. Yeah, see, that is working. Okay, so now let's create another foliage type and add to the system. For that, I already have imported this tree model. So let me just copy this, copy here. I'll call it FL or just tree. I don't have a name for this, and assign the tree mesh. So here I'll keep this 500 to 1000 and pine. No, let's mix this a bit. 500 to 2000 and pine from 1000 to 6000, and then FL tree. I'll add this one also to the foliage types, so not here, here. Alright, let's see. Nice. But this tree looks a little too big. Maybe let's try to use this scale. But I'm not sure how to use it. Oh, this is relevant to the growth. But anyway, this is changing from 0 to 1. Let's just do this. This I'll make it 1 by 1 by 1, and the tree I'll make it smaller from the model itself. Because I just imported this model, so I can re-import it. Okay, that makes the pine trees too small. So I'll make the pine. Can I re-import this? I'm not sure. Do I have the reference to the source? I don't. Okay. It's fine. We can export this first. Let's say downloads, pine one, export, and then 0.5 and re-import pine one. Oh wait, I wanted to make it larger, not smaller. Maybe 3 times. Is it too large? Alright, that seems good enough. But one thing I would like to do is the green in that tree is a bit too much, too bright. So perhaps let's use this same color. That's not really relevant to the code, but anyway. Yeah, now they don't stand out too much, but oh, pine trees are too big. Yeah, now they looks good. So the trees, yeah, the system is working. You can see this tree. Oh, some trees are floating above ground. What is that? Okay. I think I have this offset. Oh no, I don't. Is it this world space option? Oh, one thing, we forgot to add this rotation randomization. That is not, of course, relevant to the location, but anyway, I'll do that too. Just this. Just random. Is it rotation in between 0 and 360, so it will be rotated in all directions. Now let's see. Yeah, that seems like that was the issue. That's what caused to have hanging or floating foliages. All right. So I think we can reconnect this. And regarding the slope, can we get slope? Oh, what's the name of this? Ground slope angle. Okay. Slope. Right, we can access it. So first we need to calculate slope to check slope. Perhaps we can do it here. All we need is impact normal. There is get slope, degree angles. All right. Now what should I give for this? Get right vector. No, I'll just give vector right vector and flow normal, impact normal, and up vector is obviously this. So then we can check I think we should do this check after this terrain mesh check, so we can avoid unnecessary calculations. Branch. So slope, page or roll, which one we should check? Well, anything, I guess. I mean both. I think both. Let me collapse this. Check slope. Now here we can get add to foliage type and slope, ground slope angle, and in range min max. Let's do this check for both slope and roll. Min max, and then and if both are true we can place. That's not, let's see if I'm correct. Have I missed one side of the terrain? It looks like that. Okay, I guess I know what happened. So basically, let's say if the terrain is like this, and if I give right angle as this one, obviously the slope of this one would be like, I'm not sure the angle, yeah, this angle is less than 90 and this angle is like this, more than 90. So that's what I think, that's what happening here. Okay, so if that is the case, what's the angle we have? 0 to 45. We can do this. If select float if this is larger than 90, if this is larger than 90, I will subtract 90 from this and use, otherwise I can directly use that. And yeah, I can do the same thing. For the other angle too. Now we should see in both sides. Oh, am I wrong? Looks like it's still not correct. Well, I printed the values when I get those when I get the out of the range value, so it's something like this always. Either two minus values, so either one minus value and a positive value. So I think this is what happens. So if this is the reference direction we are talking about, then this angle is this. something like this. But if for a point like this, the angle is something like this. So 180 plus some value. I guess this value is, well, I'm not sure. But anyway, let's just modify this. So like this. If the value is negative, I'll simply multiply this by -1, and let's just see if it works. That's without thinking too much. Yeah, that seems to lay tile instances all over the place correctly. Considering the slopes as well. Okay, nice. Now I can get rid of this print. I don't need it anymore. So here, to test if it is working correctly, if I make this 20 and 30, as for the pine, let's see what we get. Yeah, that seems working. But we see way less pine trees because here, okay. Because I guess the angle range doesn't favor pine trees. That's fine. So yeah, the system is working. I'll make it 5 to 20. No, 10 to 20. This one 5 to 15. Ah, cool. Okay. For pine, I'll increase. Alright. So thanks for watching. As always, updated project files will be available for the download in Patreon page. Link would be in the description below, and see you in another episode. Goodbye. So in the next episode, I will restore the instance replacement logic that that is broken at the moment because of multiple foliage type introduction into the system. And goodbye.